I'm going to teach you how to test all electronic components one by one. You're going also to learn how to test components that needs power, like ICs and voltage regulators. I'm going to power the motherboards and check live voltage, check inputs, outputs, and much more. I'm going also to teach you the name, symbol, function, and purpose of each component. So stay tuned. This is the only video you need to master electronic component testing 100%. Let's get started. How to test diodes. So for diode, you have first to locate the cathode and the anode, or the negative terminal and the positive terminal. And of course, set the multimeter to the diode mode, as you can see here. So the black probe on cathode, red probe on anode, we get a drop voltage, 0.5 drop voltage. This is good. But if I swap the probes like this, upload, no reading. This is good diode. What about this one here? The big one. This is basically a Schottky diode. And the difference between Schottky diodes and normal diodes are the drop voltage. For normal diodes, we find 0.5, 0.7 drop voltage. But for the Schottky diode, as you can see, we're gonna find very low drop voltage, 0.1, 0.2. Okay, this is Schottky diode or fast switching diode. Let's test this one also. Of course, this is a Schottky diode, 0.2 drop voltage. Let's test power MOSFETs. Here we have two power MOSFETs. For this kind of MOSFETs, always we have gate, drain, and source. So between source and drain, we get a drop voltage, 0.4 drop voltage. Okay, means this is N-channel MOSFET, because when you put the red probe on source, the black probe on drain, and you get a drop voltage in the multimeter, means this is N-channel. Okay, but if I swap the probes, same as other MOSFETs and transistor, no reading, open load. Let's check this one also and find out if it is N-channel or P-channel MOSFET. Here, source and drain, we get a drop voltage 0.5 drop voltage. Okay, means this one also is N-channel. If we swap, of course, the probes, nothing in the multimeter. Those MOSFETs are good. What about this component? Do you see here we have two diodes here connected in their cathodes? This is basically a Schottky rectifier. And please attention, the multimeter is on the diode mode. Okay, we use the diode mode. So this is easy. As I told you, we put the black probe here in the middle. We check the first diode. As you can see, 0.2 drop voltage. Okay, the second diode, we have 0.2 drop voltage, same drop voltage. And as you can see, this is a low drop voltage because this is a Schottky diode. What about the bridge rectifier? So for the bridge rectifier, like this one here, we have 4 terminals and 4 diodes. The first diode, we put the black probe here in the positive terminal, like this. This is the first diode. We get 0.5 drop voltage. Second diode, 0.5 drop voltage. Then we have to put the red probe here in the negative terminal here and check the third diode, 0.5, fourth diode, 0.5. Means the bridge rectifier is good. Let's check another bridge rectifier. This one, for example, here. Here we have second bridge rectifier. As I told you, always we locate the terminals. Here we have positive terminal. We put the black probe here and check first diode, 0.5, second diode. Okay, and third diode here, fourth diode. Good bridge rectifier. Another very fast test for bridge rectifier, you can just check between positive terminal and negative terminal. If you get a double drop voltage, as you can see, means the bridge is good. Let's check this one also here. Do you see? Between positive terminal, negative terminal, double drop voltage. Good rectifier. But this is about 80%. But the correct test is to check all diodes, as you can see, like this. What about resistors? So resistors, as you know, we can base just on colors. Here we have brown 1, black 0, and orange 3. Means this is a 10K resistor. So let's move on to the resistor mode. Okay, we are now in the resistor mode, as you can see here. So this is auto range. So let's check. This is about 10K. As you can see in the multimeter, we have 9.8. Okay, so this is good resistor. What about this one here? We have 3, and we have 2 for read. Means this is a 3.3 kilo ohm. Okay, let's check. 3.3. As you can see, 3.2. This is good. So this is good resistor. What about this B capacitor? This is basically the CBB capacitor. We find it in motors. Very important capacitor here. For this kind of capacitor, you can just refer to its capacitance. We have here 1.5 microfarad. So let's move to microfarad. Okay, we have here nanofarad. We have to find 1.5 microfarad. Let's check. As you can see, 1.5 microfarad. Okay, this is good. But for this kind of capacitors, you can just test it using the continuity mode like this. Here we have the continuity mode. So let's check it. So no continuity in the multimeter. No continuity. Okay, this is basically a fast testing. If you want to avoid wasting time, you can just check the continuity, but the best way is to check the capacitance. Okay, let's check this capacitor also. Here we have 50 microfarad. Okay, this is an electrolytic capacitor with 15 microfarad. So let's check it. Okay, let's go to microfarad. We have nanofarad here, but this is auto range. And let's check. I have to find 15 microfarad. As you can see, 13.5. This is good. Okay, always we have tolerance. What about this protection capacitors? As you can see here, we find it in the input. Here we have 0.47 microfarad, means 0.47 microfarad. Let's check it. Do you see? We have 404 nanofarad, which means 0.4 microfarad. So this is good capacitors, and as I told you, you can just use the continuity mode for beginners and check. If there is no continuity like this, means the capacitor is good. So we have other kind of capacitor like those here. We find this kind of capacitors in the laptop and computer motherboard, as you can see here. So we have basically 25 volts, 100 microfarad. Let's check. So we have to find 100 microfarad in this capacitor. As you can see, we have 97, 96. Okay, so this is good. What about transistors? So for transistors, very easy. Let's first select the diode mode here. Okay, the diode mode is selected. So for transistor, so let's begin with the first transistor, this one. Let's check these two terminals. We have 0.7. This is the first drop voltage, first diode. Let's check here. Okay, so I should move on here and put the black probe here. So we have the first diode. Let's go and check this terminal. Second diode. Okay, two diodes. So here we have the base. Okay, 710 here. 706. So base emitter collector. Always base emitter is greater than base collector. Let's check this one here also. So these two terminals, no drop voltage, no drop voltage. Okay, so let me put the red probe here this time. Check here. Okay, the first drop voltage 0.6 or 0.7. Let's check this side. Second drop voltage. Okay, here we have first diode, and over here we have second diode. Okay, so 692, and here 691. Let's see, here we have emitter collector. What about Zener diodes? The same working principle. Locate first to cathode and anode, and always the multimeter to the diode mode, and if we check, of course, we're gonna find a drop voltage. As you can see, 0.6 drop voltage. If I swap to probes, of course, no reading. This is good. Let's check this one here also. Okay, as you can see, 0.6 drop voltage. Ceramic capacitors. So to test this kind of ceramic capacitors, do multimeter to farad modes. We have farad mode. Let's begin with this one. Here we have 103, means this is a 10k picofarad equal to 10 nanofarad. So let's check it. As you can see, we have 9 nanofarad. Same for this one, we have 103, which equal to 10 nanofarad, as you can see here in the multimeter. So this is good. What about this one here? So 4, 7 and 2 zeros means this is a 4700 picofarad equal to 4.7 nanofarad. So let's check. As you can see in the multimeter, 4.1. Always we have tolerance. So M means 20% tolerance. And for K here, this is a 10% tolerance, and 1 kilovolt means maximum voltage rating. So those capacitors are good. What about this one here, the ceramic or the ASMD ceramic capacitors? Let's check it. 35 microfarads. Okay, so this one also is good, but we don't have the value above it. So for this kind of capacitors, always you have to refer to the datasheet or the schematic or the donor board. What about testing transformers? So for transformers, we have to select the continuity mode on the multimeter. So the continuity mode is selected, and check all coils belong to the transformer in primary and secondary. So let's check. Okay, this one here. Okay, this is the first coil. Okay, first coil. So second coil. So this side is good. Let's check the other side. Okay, this coil is good. Other coil is good. So the transformer is serviceable. Time to test NTC resistor or NTC thermistor. Very important protection resistor. It's a resistor whose value decreases when temperature increases. So of course, let's select mode, as you can see. So basically now, if we test it, we're gonna find a very low resistor. As you can see, 2.6. We have 2.6. In a motherboard, this is it. Over here, as you can see, this is the NTC thermistor. Let's check it on the board. Basically, these 2 pins here. So let's check. As you can see, 6.9. So the behavior of this resistor is that the resistance goes down when temperature goes up. We can even check just using my finger. Look, we have 2.5. If I put my finger here, do you see? Decrease. So the resistance decreases. So the value changes smoothly with the temperature. And remember, the NTC gives its real value at 25 Celsius. What about testing optocouplers or opto-isolators? So very easy for optocoupler. If you pay attention for the optocoupler, here we have pin number 1. Do you see this dot? Means this is the pin number 1, 2, 3, 4. Here we have the diode, and here, of course, these 2 here for phototransistor. So basically, a good optocoupler is the one that gives here about 1000 drop voltage between pin number 1 and pin number 2. Let's check. So let's move the multimeter to diode mode. Okay, the diode mode is selected. Let's check between pin 1 and pin 2. Okay, up loop. Let's swap the probes. So let's check. As you can see, 1000 drop voltage. Okay, let's check this one also. So here we have pin number 1, as you can see. So let's check between pin 1 and pin 2. We have 1000. Okay, let's check like this. 1000. Do you see? 1000 means this is a good optocoupler. For other pins here, you will find up loop in both sides. Here we have up loop. Also, if we swap the probes, as you can see, we have also up loops.
What about testing fuses? We get the continuity, means the fuse is good. Let's check the second one. No continuity, no beep means failed fuse. For this one here, it's clear it is burned, so we will get no beep, no continuity. The most important is to understand how to change a failed fuse with another serviceable one with same characteristics. As you can see here, we have 2 amps for this one, 250 volts. Means you have to change this failed fuse with another one with same characteristics. Now let's test coils or inductors. And of course, to test coils, we will use the continuity mode, as you can see here in the multimeter.
Okay.
Good one. Good coil. This one also is good. For this big coil, as you can see, we find it in power supplies and it contains 2 coils. First coil, red color, and second coil. Each coil has 2 terminals. These 2 terminals for first coil and these 2 others for the second coil. So let's test the first one. We're gonna put 1 probe in the first terminal, the second probe in the second terminal. We have to get a low reading, a beep in the multimeter, as you can see. Good coil. Let's right now test the second one. 1 probe in the first terminal, second probe in the second terminal.
Okay. This is
good.
Okay. This is
We get a beep. Means the coil is good.
The board is powered, and I'll teach you how to test ICs step by step. So first you have to locate the inputs and outputs. This is basically the charge IC ISL 6251. But you gotta understand how to test all kinds of IC. So first we have to check the DCN. The first input is the DCN. So the DCN for this kind of IC, based on the schematic, as you can see, is the pin number 24. So here we have the first pin, pin number 12, 13, 24. We have to find 19 volts. As you can see in the multimeter, we have 18.7. The DCN is present, the first input. The second input is the VDD, IC power supply. So for this IC, we find the VDD in the pin number 1. We have to find 5 volts. This is the second input. We have 5 volts. The third input, very important, is enable. We have to find it in pin number 3. So let's check. We have to find 3.3 volts. So here we have pin number 3 connected to this resistor. So let's check this resistor. We have 0. The 3.3 volt is absent. Why? Because the battery is not connected. Once the battery is connected, the enable will be present here. The next input is the V reference. Based on the schematic, we have to find it in pin number 8. It's about 3 volt. So let's check. So we have pin 1, 2, 3, 4, 5, 6, 7, 8. This is pin number 8. So if we check pin number 8, as you can see, we have about 2.4. The next input, so please attention, to get the outputs we have to check the inputs. If the input is not present, we will not get the output. So the next input is the VDD or gate driver supply. We will find it in pin number 15. So the black probe on the ground, we have here 12, 13, 14, 15. We have to find 5 volts. As you can see in the multimeter, we get 5 volts. And another very important input, without it, all ICs cannot work. The boot signal or voltage. Here we will find it in pin number 16. So usually or even always the boot is about 5%. So let's check. So we have 13, 14, 15. We have 16 here. Let's check. We have 4.9. This is 5 volts. So this is basically the most important inputs. Once we get all these inputs, means this switch will be activated. Let's check. So here basically we have source and here we have drain and this is the gate. Here we have 19 volts. We should find the control signal. Let's check. We have 8 volts. Good. Means we will get 19 volts in this side. We get 19 volts. So without all inputs here, this IC will not send the control signal to let 19 volt to pass from this side to this side, as you can see. So without all inputs, we will not get here 8 volts. Means the 19 volt will stop here. It will not pass to this side. So this is how we test the ICs. Basically the ICs, you cannot test it using just the multimeter. You have to power it and test it. And of course you have always to refer to its schematic or to use its reference and search in the internet to find its pinouts. So I have a question here. How we can test ICs without powering on the board? So to test ICs without powering on the board, I'll give you basically 2 or 3 methods. The first method is to select the continuity option on the multimeter. We have here continuity option, and to check the ceramic capacitors around the IC. If all ceramic capacitors are good, no short, means the IC is good, not shorted. This is the first test. The second test is to power the board and check the heat of the IC. If the heat of the IC is not normal, overheated, means the IC is shorted. The third method is to check the state of the IC. Is it good or not? Using, of course, the visual inspection. For example, this IC is a good IC. This one here, blowed IC. This is bad. So we don't even power the board. The IC is clear. You have to replace it. I hope you understand. So please don't hesitate to ask. I always do my best to answer all comments.